Hey guys, this is Sean with learninghobby.com. Today we're going to be looking at project number 2 from the official Arduino project books, the official Arduino projects book. This book can only be purchased currently by buying the official Arduino starter kit from arduino.org. I'll have a link down in the description to where you can get that from Amazon if you're in the US. And I will also tell you that if you live outside the US, to purchase it, you'll have to go to arduino.org/starter kit and find the distributor for your country. So again, we're going to be looking at project number 2, the Spaceship interface. Does that look really cool? Now, if you get the book, you can read this. This book is really, really good. This is one of the better books I've seen with a kit like this. It's got some great information about how everything works and about some of the functions in the code. I'm going to show you some of that in a minute. So this is what the circuit looks like. I'll actually put it together for you in just a minute. Give you the full schematic right here. Now they also give you this cool little cardboard piece that you can put on it to make it actually look like a quote-unquote spaceship interface. So to move on to the next thing, let me zoom in here a little bit and we'll put this together. All right, for project 2, you need the following things. We need some Christmas LEDs. We need 2 red LEDs and we need a green LED. We need some resistors. This circuit calls for 3 220 ohm resistors and 1 10K resistor. The 220 would be the red, brown resistors, and the 10K would be the brown, black, orange resistor. Okay. We're also going to need a tack switch. Nice little switch. Talk more about it in a few minutes, and if you watched any of the previous videos, you've already seen them. We also need wires, as well as the power and ground jumpers. Of course, you need your cool cardboard thing. And finally, you need the Arduino Uno and breadboard. So let me speed this up and we'll get it put together. So before I put the cardboard bit on, let me talk to you about what's going on with this circuit. So we have up here on the power rails, the 5-volt rail is connected through this red jumper wire to the 5-volt or the power rail on the breadboard, the red stripe rail. The ground pin over here is connected through the black jumper wire to the black stripe, the ground rail right here. Now remember, these run this way. These run straight down this way. So each one of the LEDs is then connected through a data pin. We're using pins 3, 4, and 5 to make this work. So pin 3 is, how did I hook that up? I don't even know if I hooked it up right. We'll have to change the code if I didn't. Yep. Okay, so the yellow, the first pin 3 is connected to the positive leg of the green LED. Remember, there's two ways to tell which leg is positive. First of all, the longer lead is positive. Also, I don't know if you can quite tell on the video, but the negative side has a flat right here. Okay, so it's connected through this first yellow jumper to this green LED, and then goes through there to the resistor to the ground. So it makes a complete circuit there, so we can power that through pin 3. The same sort of thing happens with the red LEDs on pin 4 and 5. Now, the button is, let's explain what's going on here if you've never seen this before. So the button, we've got 3 different things connected to this button, this tack switch. Okay, so first of all, the green LED is hooked to one side of the button to all the way to pin 2. Okay, so that's where it's going to actually receive the input. Now we have a 10K resistor. It's connected to ground. We call that a pull down resistor because it's pulling that voltage to ground. Then when you push the button, it allows current to flow through this red jumper and through the switch to the green LED, and nothing happens with the resistor anymore, so then it gets a signal. So when you push a button, it pulls this pin high. When you let go of the button, the resistor is pulling the pin low. That's what makes the button actually operate. Okay, let's get the cardboard piece on so we can see our space shuttle go. All right, there it is. So the text is actually backwards and upside down from the screen. It's just how I decided to record these videos. The button goes through here and it's labeled with launch button. Boom. Okay, and then system ready is the green, and then engage hyperdrive. I wonder what that will do. Well, it's time to move on to the code, and then we'll get to see. So let's switch to the computer screen and look at the code. All right, here is the code for this program. Now, I will first of all give a slight disclaimer that the code that I write and the way that I'm going to write it is going to be ever so slightly different than what's in the book. I'm actually going to set up variables for all of our pins because I think that's the better way to do it. Now, if you have done any Arduino programming, I may do this a little bit different than you. I don't use pound define most of the time. It depends on what I'm doing, but I'm going to actually create integer variables. So without further ado, let me show you. So if you've never looked at an Arduino program before, you should know that it always has 2 parts. It has the setup right here, which is where you, guess what, set up everything. Then it has the loop. Okay, every Arduino program pretty much has both of these 2 things. What you need to know about these 2 things is that the code that's inside of setup only runs once. It only runs the first time the program opens. So as soon as you either reset the board or apply power to the board, the setup code only happens one time. The loop code, everything inside of the loop, keeps on looping. Imagine that. It keeps on repeating over and over again. So if you want something to flash, then you can just do the loop. Just for example, in case you are really, really new, let me show you real quick how to just make one LED blink, one of the ones that we already have on the board. We'll make the green LED blink a little bit for you. Okay, so the way we're going to do that is we're going to delete these comments that it automatically populates in this basic program. I like to line up my curly braces, so I start with doing that. You don't have to do it that way. That's just the way I was taught when I was in school, and I happen to think it looks neater that way. So my way of doing things, not just my way, but my preferred way of doing things, is setting up all of my variables before setup, or naming them before setup. So we have to make some, or in this case just one, integer variable, because all of our pin numbers are integers. And you remember from math class that integers are whole numbers. So 1, 2, 3, 4, 5, 6, 7, 0, and then negatives. Now in this case, an integer variable, it is just a specific type of variable that is only whole numbers. There's no decimals in ints. Okay, so it's the same idea. So we're going to make a int. In this case, I'm going to call it green. I really like to name my variables things that make sense. That way, when I'm trying to go back and debug my code and figure out what's going on, I know exactly what I'm reading. So we're going to call it green. We have the green LED plugged into pin number 2. So we're going to assign it to 2. Really simple. You have to end this line with a semicolon. That's a semicolon. If you don't know where that is, it's the button right next to the L on the keyboard. Then we have to tell the Arduino what this is, what the green is, what pin 2 is. We have to tell it whether it's an input or an output or what. So inside the setup, we need to use the following function. We need to type pin, all lowercase, and then mode with the M capitalized, open parentheses, and then we could type 2 in here and then comma and then tell it we want it to be an output. And yes, that has to be all caps. Okay, and then we can close the parentheses, and then again we end the line with a semicolon. But since we've named that variable green, we're going to change that instead of a 2, and we're going to use just the word green because the program understands that green points to 2. So we anytime we want to use that LED, instead of having to remember that it's on pin 2, we just type the word green because that's easy to remember because it's a green LED. So we've said it's an output. So now, just for example, just to get us started, we're going to make that green LED blink. Okay, so the first thing we need to do to make it blink is turn it on. So to turn it on, we use a digital write function. We type digital write. The W is capitalized, open parentheses, and we tell it what pin we want to write to. Again, we're going to write to the green pin, and we're going to turn it high, H-I-G-H. You can actually use 1s and 0s here. I typically use high because I find it easier to read, but both work. If you're trying to do fast things, then you are going to do it a little bit different. But that's a little more advanced than this video. So you close it in the line with a semicolon. Now, to make it blink, you would think the next thing you do is turn it low. So if I put in digital write green and turn it low, you might think this would blink. Let's go ahead and upload it to the board and see what happens. Oh, first time you upload it to the board, you got to save it. So let's save this as starter kit SK project 02. You can save whatever you want. It's your program, your computer. So I'm going to save it as starter kit project 2. Push save. Okay, so that uploaded. I don't know if you remembered. I clicked upload. I can even do it again. It'll upload it. You can see it's doing. You'll notice on the board, nothing is happening. So what's going on? Well, let me tell you. This is happening really fast. This is looping really quickly. So it's loop, 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 loop. So it's not happening fast enough for us to see it turn on and off. If we put a scope up to this, we might be able to see, in fact, we probably would be able to see the oscillations on an oscilloscope. But our eye definitely can't see it, so it just appears to be off. Okay. So what we need to do is we need to tell it to wait. So after we turn it on, we need to add a delay. Okay, this is a function, so we do open parentheses. I'm going to type in the number 1,000. The unit here is milliseconds. So did you do that in your head real quick? 1,000 milliseconds equals 1 second. Okay, so we can even hit tab a couple of times here. and put a double / to put a comment. We can say this is a 1 second delay. Okay, so when we upload that, oh, it's still nothing happens. Nothing's going on. We can't see anything happening. So, what's still wrong? I'm actually surprised that it's not showing on, which may mean that I'm doing something wrong. You know what? I am doing something wrong. Green isn't plugged into 2, it's plugged into 3. This is another advantage to doing it with a variable, because if I had done it instead of with a variable and just hard-coded in the number 2 here, I would have had to change 1, 2, 3 things. But now I just have to come up here and change this number to a 3. Done and done. So we re-upload it, and this time, what will happen? Nothing, apparently. Oh, I forgot one other thing. I actually didn't forget it. I did it in the earlier video, but this is actually a different day that I'm finishing this video, and I forgot to re-plug back in our power and ground. So real quickly, let's plug in power and ground. You see, everybody makes mistakes. I'm actually going to leave this in there. I could re-edit this, and I could just cut it out and say, and you would never know. But I think it's important that you see that everyone makes mistakes. Okay, so I'm going to plug in the black jumper there. I was wondering, I couldn't remember why I did that. So now it's already on, because we're really only using the ground rail for the LEDs. So it's on. You'll notice it's not blinking. I'm going to go ahead and plug this 5 volts in. You notice it is not, in fact, blinking. Why is it not blinking? Well, let's look back at the code as soon as I get this red jumper plugged into the power rail. Done. Okay, so the reason why it's not blinking is because what's happening is it turns on, and then there's a 1 second delay, and then it turns off, and then comes right back around and turns on again. So we never see the off cycle. So what do we need to do? You guessed it, didn't you? We need to add another delay right here. Okay, so we're going to add another 1 second delay in line with a semicolon. We could even put in another comment here, and we could say 1 second delay. Now when we upload it, our green LED should blink. It, in fact, does blink. Yippee skippy. So that's all well and good, and that's nice and basic, but that's not what this project is all about. This project is about making this launch button do something cool. So first thing we need to do is we need to have variables and pin mode setups for everything plugged in. The 2 red LEDs, the green LED, and the button. So we're going to make variables for all of these things. So we're going to make another int. We're going to call it red1. And we're going to assign it to 4. Next thing is to make another one. In fact, I'll skip ahead a little bit and show you what this looks like. Okay, so this is not quite right because the button is not an output. So we need to change this to input. Okay, so now they're all set up, and we're not going to actually use any of this code. What the project does from the book is it has the green LED, and then when you push the button, it has the reds flash on and off. It has the reds flash on and off pretty fast. So we're going to write that. Okay, so they use a variable. They call it switch state, which is a pretty good variable. So we need to go ahead and add that in there. We're going to use an int variable. We're going to call it switch state. I'll show you what that means here in a minute. switch state. Okay, and they started out at 0. Now this is a little different, because there's nothing plugged in on pin 0, so this is not going to represent anything that's plugged into the board. This one is going to actually be used for some logic. I'll show you what we mean. The first thing we're going to do is we need to read the current state of the button. So I just showed you a digital write. In order to read an input, we need to use digital read. So that's what we're going to do. So we're going to now, at the very, very beginning of the loop, we're going to assign switch state what is coming in on the button pin. So we're going to do switch state is assigned digital read. And what are we going to read? We're going to read button. Remember that button is holding the number 2 right now because that's the pin that the button is plugged into. And, I put a comma, but digital read only has one parameter. We just have to tell it what we're going to read. So we're going to get a reading from the button. So now switch state is holding either high or low, a 0 or a 1, whether the button is pushed or not. Now you remember that we have a resistor plugged into or hooked up to that pin, a pull down resistor. So when it's not being pushed, its state is a 0. Okay, so right now it's 0, and then I push it, it's a 1, or you could say it's low currently, and then when I push it, it goes high. So we need to do a little bit of logic based on that. Okay, so the first thing we're going to do is use an if statement. Now, if you're really new to programming, this might be a little bit confusing. Hang with me. I'm going to go slow so you can get it really well. If you're really great at programming already, this might serve as a refresher. You may be able to skip ahead a little bit and just take a look at what's going on. So the way you do an if statement is really simple. You type the word if, and then you put a condition inside the parentheses. I hit a button. So try again. If, and then you're going to have some condition. Now, the condition isn't actually going to be the word condition like what I wrote here. Just wanted to make sure you understood what I was saying. So we're going to say if the switch state. Now you have to put 2 equals. You remember I've been saying is assigned. The equals in programming actually doesn't mean equals by itself in most programming languages. It's an assignment operator, and what it does is it takes what's on the right side of the equals and sticks it into what's on the left. So in order to actually say equals, you have to put 2 equals signs. So if switch state equals low, so again, that's not pressed. So right now, this would be a true statement, okay? So if that's true, then what we want it to do is, now you have to put a curly brace. So that's shift and the button beside the P. And then you go down, and I like to go ahead and close it so I don't forget. And once I start getting to more curly braces inside the loop or the setup or whatever, I like to go ahead and add a comment right after it, reminding myself what this goes with. So we put a // and I like to just say end if. That just reminds me that that's what this ending curly brace is. It's so that it doesn't get confusing later. So then I can go down here and add end loop. You definitely do not have to do this. Remember, comments, the compiler and the Arduino, they don't really read them. They just throw it out. This is just for us. This just helps me keep sane as I write programs and as the programs get more complicated. So inside of the curly braces, we need to put what happens if this is true. So if this is true, remember what I said, and if you have the book and you're following along, what we want to do is we want the green LED to turn on, and we want these to be off. So how do we do that? You remember you use a digital write to turn the LEDs either on or off. So that's all we're going to do here. We're going to do digital write. And what do we want a digital write to? Well, we're going to start with the green, and we're going to turn it high. the text on the little thing says system ready. So that's kind of goes with the mythology of this project. So then you have to close the parentheses and end the line with a semicolon. So you're turning it on if the button's not pushed. Just because we're going to need it later, you want to go ahead and turn the other ones off. So I'm going to copy and paste here. So copy and then paste and then do it again. And I'm going to change green to red 1. And I'm going to change high to low. I guess I could have copied and pasted the second one. And then red 2 is also going to be low. When you see low, you might want to think off or no input if it's an input. Okay, so if the button state is low, so not push, just turn the green on and the red heads off. At this point, we have enough to go ahead and test again. Always test as you go. That way, if you have an error, you don't have to look through 5 million miles of code to figure out where in the world your error is. So go ahead and upload that code there and make sure you did everything right. Okay, so you see that it's turned on. Now, right now, if I push the button, nothing's going to happen because I haven't told it to do anything if the button is pushed. So the code never actually turns off the LED yet. So it's still on. So once it's on, it stays on because we never told it to turn back off. It's kind of like a minute ago when the thing wasn't blinking. Okay? So now we need to use another special word. So that's if. The next word is, when you're saying either this or something else. If you want to choose between two options, the fancy word for that in programming is else. Else doesn't have a condition because it just says if this isn't true, do this. So if this is false, then that means the button has to be pushed because then it would have to be high. So else do this other thing. So we're going to do open curly brace, closing curly brace, // end else. And this is definitely not the way they wrote the code in the book. And a lot of people don't do this, but I found in some of my robotic classes and other things that this is really handy. Okay, so if that's not true, we want it to start blinking the red LEDs. We already know how to do that with just one LED. It's the same process. So the first thing we're going to do is we're going to go ahead and turn the green one off. So we're going to do a digital write. And we're going to do green. And we're going to turn it low. Good job. Easy peasy lemon squeezy. So now we're going to take this. We're going to copy it. And we're going to paste it. And then paste it again. So the first thing we want to happen when we push the button is we want one of the red LEDs to turn on. So we're going to change this to red 1. And we're going to turn it to high. Now, if we want them blinking back and forth, we want the second red LED to be low. So we're going to keep it low, change it to red 2. Then we're going to wait a quarter of a second. So what number would that be? All right, I'm staring at you, just like Dora the Explorer stares at you. It'd be 250. Okay, so we're going to do a delay of 250 milliseconds, which is 1/4 of a second. So pretty fast. Then we're going to go ahead and copy all 3 of these lines because you want to do something with all 3 LEDs again. And actually, that's a lie. We really only want to do something with the 2 red LEDs because the green LED we just want to keep off until the button is not pushed again. Okay, so we're going to copy that stuff, and then after the delay, we're going to paste that in there. So we can come back in and add comments. Let's see, add the comments right here. So green LED on. And we could add a comment right here that says button not pressed. Then down here at the else, that would mean the button is pressed. Sorry, I should add those as I went, but sometimes it's good to just kind of keep on a train of thought and then come back and add them in there. So then if the button's pushed, then we're going to blink. Whoop. Blink is a reserved word. I wonder what that is. I have no idea. So // blink red 1. And then we're going to blink red 2. So we're going to just switch these words. So this is low. This is high. Then remember, just like last time, we still need to add another delay. So we're going to add a delay down here of 250 milliseconds. Now let's upload and see what happens. So, see, the green is on. Then we push the button and blink, 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 blink. Yay, happiness, we did it. That is the end of project 2. See, when you let go of the button, the green one turns back on. System ready, engage hyperdrive. Okay, it's a little anticlimactic, but still a really decent second project. I like it. I hope you like it. You need to go out there. You need to make something happen. If you've enjoyed any of these videos, I would love it if you would like, comment, and subscribe. Also, you can go and check out learninghobby.com for more tips, tricks, tutorials on electronics, robotics, hair products, whatever, all kinds of cool hobby stuff. Get out there and make something happen. Adios.